Hello, I'm Roberto, and we are learning Rust. Also today, like always, here with us, Luciano.
Hello, everyone.
If you don't know this channel, in this channel we talk about Rust and technologies. You can find a recording of the previous stream on YouTube, and if you're watching this on YouTube, we stream every Monday, 6 p.m. Dublin time on Twitch. Today we are going on merging a pull request for our step function that is creating Luciano's newsletter, the Full Stack Bulletin, and we will address a problem that we found with the production run of this step function. And we have time left. We will start with some code extracting the number of campaign, the last number of the last newsletter. Let's call it campaign. I think because it's called campaign from the web page that has the list. Yeah. So we are going to do all of this today.
So busy agenda.
Do you want to share your super busy? Do you want to share your screen so we can start?
Let me share my screen. Yeah. Okay. So just as a reminder, this is fullstackbulletin.com. I'll add the link in the chat. And it's basically a newsletter, weekly newsletter for full stack developers, semi-automated. We are working on the automation, which is basically we share links on Mastodon every week. And then at the end of the week, there is a preview, kind of a draft, let's call it, campaign that is generated from these links. All of that is implemented with a step function, and we have been working on this step function on AWS, which right now looks like this. So basically there is a start, there is a fetch data parallel step where in parallel we fetch different types of data, quote of the week, book of the week, and the links from Mastodon. And then all of this data flows into another step, which creates the issue on basically on MailChimp. Takes all this data, uses a template from MailChimp, creates the draft there, and then we can edit manually and send it. So that's all we have been busy with. Originally, this was done in a single Lambda. Actually, I'm going to share the repository as well if you're curious to check out the code. And we started to decompose it into step functions for several reasons. One, because it's more maintainable, it's easier to debug, and also because we want to rewrite some of this in Rust. And I think it's just easier to, if you have step functions, to do it incrementally because you can just swap out small pieces one at a time. Anything to add there, Roberto?
No, I think it's everything.
Cool. So last time what we did was move out this fetch links step, which was still, so we started from this create issue was the mega Lambda that was doing everything. And we started to move out small bits and pieces. We moved out the fetch quote, the fetch book. Last time we did the fetch links. Here there is a PR if you're curious to see the changes. Otherwise, you can check out the previous recording, which is on YouTube. And what I'm going to do now is just merge this one, and then we'll start to work on the other issue, which I'll show you in a second. So squash and merge.
And so what kind of issue we had in production?
Where is my terminal? Git checkout master git pull. Perfect. Git checkout, let's call it B default parameters. And let's explain what that means. So last time we had this for a while. So at some point we introduced a feature called dry run that allowed us to test the step function without actually creating a campaign in MailChimp. So it was doing everything else up to the point where it needed to call MailChimp. And at that point, if the option dry run was true, it would then create the campaign. If it was false, it would actually create the campaign. And this is just to avoid us from having to delete campaigns every time we were testing something. But the problem is the way we implemented this, if we look at the code of the state machine, which is here, we basically expect this value dry run to be present in the input. What if this value is not present, right? When the automation starts, it starts automatically every week. It doesn't really send anything in the event. There is just a timestamp of the current execution. So dry run is not there. So in reality, what was happening, because dry run was not there, is that the execution was failing. And if we look at the issue is saying dry run could not be found in the input. So the way I was working around this, I was triggering an execution manually, saying dry run false, and that will work as expected. Of course,
In
this
the
is
chat,
not...
in the chat, they are asking us if we test the step functions, if we write tests for them. You wrote tests for the single lambdas, but not for the step function on its own.
Yeah, that's a very good question. So let me show what we did. We have some basically unit tests. That's the extent of all the tests we did so far. So for every function, we might have some unit tests like this one, or I think in the fetch links, we have more tests. There are a bunch of tests here. Here we have more tests. So there are quite a good amount of unit tests. We didn't really spend too much time doing more kind of end-to-end tests, running the step function and checking that it does what it's supposed to do, which is something that we could do as well. But right now hasn't been really a priority for us. I hope that answers the question, but feel free to ask more questions. Okay, so where was I?
So we have this default value that is not there, basically.
Exactly.
So when it runs with the cron, it gives you this exception because dry run is not there. It's not even undefined because...
Exactly. Yeah, so just the mapping of the state doesn't find the property and crashes. So I was chatting about this problem with Owen Shanahy, who is the CTO for Theorem, the company I work for. And we were working, well, we have this open source project called Pod Whisperer, which is actually something quite interesting if you need to do transcriptions of videos of some kind. So I'm going to drop the link here just in case people are curious to check it out. And it's also implemented use step function because it needs to orchestrate across different services. It uses AWS Transcribe. It uses OpenWhisper from OpenAI. So it's kind of its own model running in a container. And basically then it takes the result of those two different algorithms to transcribe audio and get text, and then merges them together just because they have different characteristics. One is very good at finding different voices and telling you another person is talking now, while the other one is much more accurate in terms of the quality of the transcription itself, so that the ratio of correct words versus words that are not really matching the actual spelling. So one thing that Owen was doing here, which I think is pretty cool, is using this idea of creating an initial step called define defaults of type pass, which basically means there is no compute, it's just pure mapping of state. So it doesn't really apply any...
And this is a step of the step function.
This is a step of the step function, which runs as the very first step. So we will have an initial node, then our 3 parallel nodes, and then another node at the end.
Okay.
Then the trick here is that we can set parameters, right? And these parameters will become part of the state. And then wherever we want to merge those default parameters with something else, we can use this states.json merge. And this is a bit of a interesting thing. What is the states dot? In step function, there is something called intrinsic functions. I'm going to actually drop the link there in the chat. And basically, there are a bunch of utility functions that you can just use to do simple things. And sometimes they will save you from having to write additional Lambda functions. So this JSON merge is another intrinsic function that we can find here. And it basically allows us to take one JSON object, another JSON object, and combine that together. So basically means that we will have a dry run false if we pass a dry run true, it's going to override the default. Otherwise, we will have dry run false as a default already there.
And what is the third parameter there that false?
What is the third parameter? Let's see. I don't know. Good question. There should be some documentation. Merge two JSON objects into a single object. This function takes 3 arguments. The first 2 arguments are the JSON objects that you want to merge. The third argument is a Boolean value of false. This Boolean value determines if deep merging mode is enabled.
So basically, in the example there, you have A that points to an object, and we have deep merging off. So it's going to replace A with the second object. Instead, probably if deep merging was true, we would add out of it an object with 4 keys.
Yeah, it's losing A1 and A2 basically.
Yeah. Instead, probably with that parameter at true, it was merging the object in A. Mm-hmm. Instead, with false, it's just looking at the first key of the first level. And so we have to keep our defaults as JSON1, looking at this example, and the parameters become JSON2.
Exactly. We have another interesting question. Thank you, Shubham. Is how do you choose between AWS Lambda and step functions? That's a good question. I don't think the choice is necessarily between the two, but it's more from an architecture perspective. When do you need to use step functions on top of lambdas? Because most likely with step function, you are still using lambda for the kind of your own business logic part. So in this particular example, we had this newsletter, lots of integration steps, taking data from different places, manipulation, data filtering, call different APIs, upload images, all these kind of things. And it was getting a bit out of hand, everything in one single Lambda. This Lambda alone was taking something like 1.5 minutes to execute. And the idea was that every time something was failing, it was very hard to troubleshoot exactly where is something going wrong. Even if we had logs, it was still a bit confusing to figure out exactly in which step, logical step, things were failing. So here the idea of introducing step functions was more, if we start to move things into like a visual representation of the flow, then debugging this is going to be much easier. Every time we execute it, we have a trace of exactly what's happening in every single step. What is the input? What is the output if there were errors? But also we were able to parallelize a bunch of different things without having to do that in the code, which simplifies the code even more. And finally, because we want to rewrite some of the stuff in Rust, it kind of gives us that extra freedom of just pick and choose which steps we want to rewrite in Rust without having to rewrite everything. So I guess in general, it's more when you have a workflow, step functions are convenient. Otherwise,
I would add that with step function, all the parallelization is handled by parallel execution instead of you having to think about it in your code. Mm-hmm. Not that it's impossible, but it's something you don't have to think about because it's done for real in parallel. Mm-hmm. It's not that you have to think about global interpreter lock or whatever. And another point is, for example, before using a step function, when step function was still young, I was using S3 buckets as a coordinator for the intermediate step of the object between lambdas, with triggers on top of file creation to trigger additional lambdas. So basically, it was like having step function with the intermediate state in an S3 file, and then lambdas that were triggered by this. And while this was, it was better than having a monolithic lambda for execution, time execution problems, and also you had the intermediate step to look into them. It was hard because it was with a no UI at all. The UI was the S3 bucket. You had to look at what was the execution UUID of that time, track the files through the bucket. Here you have everything in one place, in one handy UI.
There is a very interesting article. I'm going to drop the link here in the chat from Yan Chui, who is a serverless expert. And the idea there is that you can either do, in an event-driven system, you can either do choreography or orchestration. choreography is basically when you try to capture events flying around and react to events. So you have a kind of a implicit workflow defined just by the flow of events and event listeners that react to events. With step function, you are more doing a more explicit orchestration where you actually design exactly what is the entire flow, and you track every single execution of the flow. You track the share state of that flow. And if something fails, it's much easier to see. So, of course, the two things have their own use cases. It's not that choreography is necessarily bad. It's just when the workflow needs to be very explicit. I think something like step function and orchestration is more appropriate.
Without knowing the name, I was describing choreography. Now I also know the name. Yeah. Thank you, Luciano.
Okay, so what were we doing? Now
let's try to add those. Those are 2 steps, right? Not 1, 2 pass.
Well, step. I think we can use the state. Let's see. Yeah, actually, we can probably define it in the same way as here. Yeah, I like it. So because otherwise we will need to use JSON merge somewhere else in the other steps, and it doesn't feel too clean. So let's probably copy this one. What am I going to do in a very dirty way is just copy this.
We have YAML and this is JSON also.
Exactly, and we'll need to reshape it manually. So it might be fun.
Joy, we have to reshape it.
Get ready for some mess. Exactly.
So our state machine again is in the state machine folder. Cool. And now we start with the fetch data, though we don't have to start with the fetch data anymore, but we have to start with the default, whatever.
So wait, I'm just going to do it this way. Copy paste.
Okay. Leave it there.
And comment it out. Can you comment it out? No, it doesn't like it.
No. Leave it there.
Whatever. Okay, we'll fix it. So we need to add a new state, which is called, what did we call it here? Define defaults. I like the name.
Change line 23. So we start from it.
Yes. Type pass, and we start from it. Oops. And now the next step, well, we also add another step, which is apply default.
It is again of type pass.
Type pass.
And the next of this one is fetch data.
The next of this one is apply default, and the next of this one
is apply data. Fetch data, sorry. Fetch data. Fetch data.
Fetch data, yes.
Sorry. Cool.
Okay, sorry, there is one more question there in the chat. Thanks for sharing. I'm also facing a timeout issue in a Lambda function I wrote. I will look into step function if it fits there. Yeah, I suppose if your Lambda is doing a lot of stuff and you can split it down into multiple independent steps, you might be able to basically avoid also the timeout issue. You can also extend the timeout up to 15 minutes. Generally, if you need more, probably Lambda is not the right use case there.
Yeah, it's not the right solution for your use case.
Yeah, exactly. Yeah. Better put that way. Okay, so what do we do here? We can probably copy this result path, input defaults, and then our parameters is just going to be dry run false.
Okay.
So this one will need to YAMLify. And then
luckily, it's not that big difference.
Parameters, look at Copilot. It's trying to help us.
Yeah, it's wrong, but thank you.
And false. That's what we need. And that's pretty much it, I believe.
Instead, for apply, what we need to do?
So we can delete all of this. For apply, what we want is result path. So basically means keep everything.
We need to specify that if we keep everything,
I think it's the default actually. Let's not
yeah, exactly.
specify it.
I was thinking the same.
And then we have parameters is basically inputs dollar, input defaults, execution input.
I'm not super sold on this one.
I think we might simplify this a little bit. What if we do dollar?
Can we do dollar directly there?
And here we just do...
What is the double dollar on the right? It's the second input. Okay, cool.
I'm just curious if we can do this all together. And here we just do execution entirely. So we're basically saying whatever is being passed as the event, I think this should be the event. What we merge is just dry run.
Yeah, but now input defaults, where is defined? It's not defined anymore. Okay, you.
I don't think we need it. I think it was just a key. Like it was just to keep the defaults around.
Well, if it's not working, we can see at every step what we have and debug it, right?
I think so. So
I saw that for some, there is also a command called sync -- watch. Have you ever used it?
I have seen it, I haven't used it, so we can try, I guess.
Do you want to try? No, well, we are doing Rust stuff next. I don't know if it will break.
Let me make sure I am logged in correctly. Well, I am. Okay, SAM deploy. Let's see what happens. Actually, I need to set up the region.
So the artifacts are not changed, so it should not deploy the lambdas. It should only change the state machine.
Exactly.
Let's see if it's true.
It is true. Modify the state machine. Why is modifying the create issue function?
You merged and now you are in main. You do it.
Did I do a git pull? Let me be sure. Git pull origin master. Already up to date. What did we change?
There is a way to have the difference between the artifact that is up and the one you want to upload? No.
Not sure. Okay, let me do one thing that I want to do anyway. I want to set this one to true. So initially, if we run it, I'm going to deploy. But now with dry run true, when we run it without anything, it's still doing a dry run. So we can validate that it's working.
It's working. Then you just have to change it to false before the stream send.
I think there was some comment that we removed from last time, something like that.
Okay, well, yes. The artifact is different.
Let's trust that our Git was good enough, was in good state. Maybe we should have added end-to-end tests.
How do you add end-to-end tests to a step function?
Yeah, I guess it's a bit tricky because you need to effectively... what I will do is run the workflow, and then what you can do, you can also use the step function API to get the description of different steps if you really want to kind of drill down and test that different paths are being executed.
With SAM, you can trigger an execution from the command line.
Oh yeah, you can also
invoke the step function from the command line with SAM.
I guess
once
you did you try that?
No, I know that you can, but I never tried. But in our case, I think it's possible.
Okay, otherwise you can still invoke it with the SDK, with the CLI, sorry, AWS CLI. Might be a bit more verbose, but should be doable. Okay, now that it's deployed, we should be able to go here and run it again without specified dry run and see what happens.
In theory, if you do sem remote invoke the function -- stack name and the name you give to the stack.
So here dry run is true, apply defaults.
What we have out
I
of it.
don't like
JSON
this.
no, that is not correct.
Yep, this is gonna explode. It did explode, in fact. So it didn't execute this function. I guess, how do you do?
Okay, dry run is missing. What is coming out of apply defaults? What we wrote, literally.
Yeah, I think it looks for like a $$ or something.
Yeah, just dollar as a key was not convincing me. Can you edit it directly here in the UI without going back to change the code and deploy again? That will take more time.
We can try, yes. So if we do edit state machine.
I don't always debug, but when I do is in production.
Okay, let's use the Workflow Studio because it's a bit nicer. So what we can do
back a little bit, yeah.
Here is output. What if you do $?
That was exactly what I was suggesting to try.
There is
try that.
There is a simulator. I don't remember where to access it. There is like a workflow simulator.
What simulator? We do like real men. We run it.
Oh, data flow simulator. There we go.
No.
This could be useful.
Only that our input is empty, right? Our initial input.
Our initial input is empty. Let's do that.
And then we have the, what are we changing?
Input path. Input path.
We are not defining input path. What we are defining
it's like this.
State.
It's just $. Then next parameters is dry run true. Then what do we do next?
This is what is out.
Result. This is what is producing by a imaginary lambda.
By the imaginary lambda, yeah. And what we define after that?
Then result selector. Well, it doesn't really matter because we are not running a lambda yet, right?
Yeah.
Result selector. What did we use instead? We used
parameters.
I'm wondering, do we need this at all?
And how do you apply the defaults?
Yeah, then? You still need to merge with execution. Okay, let's try.
Go back to parameters.
Parameters where? Here?
There, yeah. Instead of dry run true, try to write $. On the left. Instead of dry run as a key, $. Colon, and then, yeah, you're missing a call, something.
Yeah. The execution thing, what is it?
Yeah, .execution. I don't know. So. What is the output of that guy?
It's just an empty thing.
An empty key. But we don't want an empty key. We want something at the very root level.
Mm-hmm.
How do you put stuff in the root level? If you just leave $, that is going to break, right?
Is just gonna interpret this as a literal.
That is what we did.
What if you put $? Nothing.
It must be $, and what
If
is
you do
before the dot?
$, it's just gonna use $.
What is before the dot is the key.
Mm-hmm. So we need to use.
Case, we need to use a container, otherwise it's
exactly.
not going to.
So we need to do what Owen was doing. There was a reason for it.
Probably there is some trick.
Okay, let's keep it simple. Trick. So,
but well, we can always change the output of it to extract the key to the root level, probably. And then you have to change.
Let's call it config, I guess.
But it's not config.$, not
config.$. Sorry, good catch.
Yeah, and then there is a step if you go back to that simulator.
And here now we can take just config, right?
I think so. Yeah.
Is it $config? Yeah.
$.config? No.
All right, this guy now needs to be 0. Yeah, because here you just have the array.
Because this is the result selector.
Mm-hmm.
I'm a little bit confused. But let's try.
50% confidence. This is
okay, cool. 50% is a lot. It's more than me.
Okay, let's deploy, and then I think we have more questions there in the chat. Where can I read more about synchronization and causality? I came across the words in Node.js design pattern book. Preface, mutexes are replaced by queue, threads by callbacks, and synchronization by causality. Oh, that's a good question. Let me deploy first. I guess this is more on the difference between concurrency and parallelism. It's a big subject, so I don't know if I can answer now in a short way. But in general, if you search for differences between concurrency and parallelism, probably that kind of gives you lots of background.
I think there is a good talk from, I don't remember if it was Rob Pike, talk about concurrency is not parallelism, or if it was Raymond Ettinger.
I remember one by Mr. Pike for sure.
Yeah. Okay, cool. So was that one. That is applied to Go, but it works for any language. I mean, Go was just an example. Put dry run? No.
No, because we have dry run true by default.
Ah, okay, cool. Sorry, you're right.
Now we have defaults dry run. Then config.
There is also dry run.
Oh, because it took everything. Right.
You took all the execution.
But it's working because then here what we get is config everything.
Yeah, probably.
And
we can use some key to filter the output, I suppose.
Yes, or let me check here.
I mean, in that apply default step, we can use something to like result path $.config.
Mm-hmm.
What is going to give you if you do result path $.config?
So result path is where do you inject?
Ah, okay, no. So I wanted something else then. God, I need to print that out.
There is another step. Oh, that simulator, why did I close it? Because it was useful to think about.
Yeah, to remember the steps.
Data flow simulator. So you have state input, input path, parameter, task result, result selector, result path.
Let's try result path.
Output path. Let's try result path. So it's basically, for instance, let's take this one. If you have modified payload and you take task result, what does it give you? It just injects.
It's putting them inside. Okay,
Yeah.
no, I want the other way around.
I think we want the result selector, which is, this is the entire result, and we want to map things around, and this is what we get.
Again, try to do $$ instead of body dot.
I think it's just going to be an empty property.
It's always working the same way. Okay, cool.
But what we can do there is
just have dry run in the config and not all the objects.
Yeah. So result path, right?
Was result path? No.
Result selector.
Selector, yes. Not path.
Result selector. It's an object where we need to map $config. How did they
go back to the
config dot dollar. Config dot dollar, and then we want to pass the dry run basically. So we do the
config dot dry run.
Is it gonna work?
Let's see.
Field is not supported. Why? Oh yeah, because a type pass doesn't have a result.
God.
Okay, so how do we do that? Output path.
Okay.
The output path filter allows you to filter the final result before it becomes the state output.
Okay, let's try with this one. Output path $.config.dry_run.
Could make sense. Config dry run. But then do we lose the dry run property?
I don't know.
Does it just become true or false?
I have no idea.
I think so. Oh, you know what we can do? I don't know why I didn't think about this early. Well, no, because if we do execution.dry_run, we have the same problem again.
Yeah, because it will not be there sometimes.
Okay, I'm tempted to leave it as it is. It's a bit noisy, but...
So you remove the output?
Yeah.
Okay, let's leave it like that. We have just to change the code to look inside config. No, because we are extracting it in line 22. Okay, cool.
So from the perspective of this step, let's go back here. The input is clean because it's quote, book, links, and then there will be dry run somewhere. Dry run true. So for the step is clean. Here is a bit messy because here if we look at the input, we have extra fields.
Now, if you... So we changed nothing. Right?
I'm thinking here, this input, where is coming from?
Okay, if you call now with dry run 1, what is happening?
Let's try that.
Because for the code, dry run 1 or dry run true is exactly the same.
Good idea. Yeah, let's try that. So if we do dry
run 1. Where is going to put that dry run?
So here is dry run 1 and comment. Apply default is dry run 1. This is the input. What is the output? Is dry run 1.
Yeah, but there is a dry run in line 5.
Oh, it's going inside input.
Yeah, we have to extract it from input.
This is good, I think.
Yeah.
This
Because
is
instead
actually
of
good.
executor,
Okay.
we do executor.input.
Exactly. So here we do dot.
And we remove also a lot of noise. And the input is always there because even if it's an empty object, it will always be there.
Okay, let's redeploy this and let's try
I'm not
again.
sure that this is true, but we can try to execute. When you run it through the cron, you are passing an empty object as a start state.
No, I think the event of a scheduled event is just a timestamp of when the event was triggered.
But inside an object or row?
I think it's execution time. So it's an object with just one property called execution time.
Okay, but it's an object. So the
we can actually
part
check.
is...
Let's check while this is deploying. If we take the one that failed, what was the input?
Yes.
Sorry, not this one. The previous
Good
one.
stuff about step functions again is that
easy?
debugging this is easy.
So input. Actually, there is a bit more. I thought it was just this time, but there is also a bit more stuff. Yeah.
No, but it's fine. It's an object. Important is that dot input is not null.
Okay, so was this deployed? It was. Let's execute again with dry run 1, right?
If you want to test it, yes.
Rune.
We talked about Go and now you have Rune in your mind.
This is a nerdy reference, only for real Go developers.
Okay. Real. Anybody that used a string in Go.
Okay, dry run 1. This is the input. Wait, no, that's correct. The output is correct.
Okay.
And then here, what do we have? Input
dry run 1
is dry run 1 and only the comment. Perfect. And create issue is dry run 1.
And so it was not running because for the code, the dry run 1 is still true. Cool.
Okay, so we need to set the dry run to false because that's our real default.
And do a commit.
Do a commit, and then we can do a PR. And I don't know how much time we have left for Rust, but we can probably get started.
But we can start adding an empty Lambda for now that is returning a number.
Logic to handle default values for the state. My favorite CLI command, which I cannot mention on stream.
Yeah, it will be demonetized on YouTube.
Okay, we can open a PR in here. Well,
and here we only touched the state machine. So for now, well, we have to touch the state machine to add a Rust Lambda to the flow. So we can make a branch starting from this branch just to avoid conflicts.
Or we can merge this one. I mean, if we look at the changes, should be quite reasonable.
Yeah, we just add the state and the default. You can merge it.
Let's wait for the CI to finish.
You have to wait a little bit. Okay, in the meantime that the CI goes on, what do we need to add an empty Rust Lambda?
So there is a tool that is called Cargo Lambda, which I think is the one we want to use today because it's very convenient. And what it does is, if we get started, I think it's fairly good here, the introduction. So you can say Cargo Lambda new and the name, well, the folder that you want. And this is going to do a scaffold of the effectively everything you need to write a Lambda in Rust. And to write a Lambda in Rust is a bit tricky because there isn't an official runtime. So it's effectively a Rust binary that also includes kind of a your own custom runtime, but it's effectively a library provided by AWS. So it's giving you a structure that is effectively the structure that AWS itself suggests to be able to do a Lambda in Rust.
And we have to do this inside our folder with the other Lambdas?
We can do that, I think, in the same folder there. So it can be in line with the other Lambdas.
So do you already have this installed? Or
I should have it installed. Now let's squash and merge. Delete this branch.
checkout
Go
master
back
pull
to here, git checkout master and git pull.
check our, because
okay,
it's not yours, it's ours.
Checkout B, and let's call it Lambda fetch issue next issue number.
Yeah. Cool.
Okay, so we have a function folder there. So what we can do is cd functions, and then we can do cargo lambda new, and we call it fetch issue number. That makes sense?
Yes. But you call it the branch next issue, but issue number is fine.
Is this Lambda function an HTTP function? No.
No.
Okay. AWS event type that this function receives.
CloudWatch event.
Can we do a custom one? Now I'm curious.
Well, because oh God, because the first Lambda of all the flow gets a CloudWatch event, but we are getting a JSON.
And it could be anything, because when you trigger it manually, you can pass all the JSON you want. So it's not necessarily a CloudWatch event.
Yeah.
So I think we can change it later. So let's just pick whatever. CloudWatch. I don't know.
There is not something like nothing.
Yeah, I wish there was like generic JSON, because you can do generic JSON for sure. Let's just take an S3 event for now. We'll try to change it later. Okay, let's see what happened there. Now, if we go to function, we should have a new folder. In this folder, it's a Rust project. We have a cargo toml. Notice that there is this Lambda runtime, which is the library that we are using that implements a custom Lambda runtime in Rust. Tokyo, which is the async runtime that AWS uses for pretty much everything. Tracing and tracing subscriber, I think those are optional, but these are very convenient libraries for doing logging and metrics. Okay, so now if we look here, look at this, there was an issue there. If we look here, this already created a structure for us. And okay, this is our function. This is our handler, basically, where we can write our code. And it's using Lambda S3 event. But I think what we can do is to use ser.json and use just a value here if we want to have a generic event.
Okay, Lambda event, S3 event. The event is our
yeah, I guess
object.
This is because you can... why it doesn't autocomplete? Rust Analyzer is dead. Oh, I guess it doesn't understand if we don't open VS Code in that folder. So let's do that. Code of fetch issue number. Okay, now do you understand? Dear, it's fetching metadata. On, you can do it, loading.
It's compiling.
It is compiling, indeed.
So, and what are we going to return? Because we want to return
the
an
issue
object,
number.
yeah, with the issue number. Then we will merge it with the dry run with the fancy syntaxes that we don't know very well.
Yes.
Yeah. At the end of all of this, we will be able to do something with all of those syntheses.
Okay, so context, payload. So payload, so now it's working. And you can see records. Records is an array, so we can do, I don't know.
First.
Records dot first. Is there a first? Yes. Unwrap S3.
Yeah, then we have S3 objects because this is an S3
sides. Yeah. So this is the advantage of using typed events, that you can do all this.
Can we just go directly with CERD and nothing
think
else?
So. I think what we need to do is to explicitly install CERD and CERD.json. So what we need to do is cd fetch issue number, cargo add CERD. Feature derive. I don't think we need to derive because we are not going to create our own custom objects, right?
No, I think it's overkill for now.
And then we can do CERD.json. Cool. So what we want to do now is basically say here CERD.json value. And this is a generic JSON event. And now we don't need this string event anymore. And Lambda event, actually, we still need Lambda event. Sorry, we just need to say that's the thing.
Do we need to wrap? Okay, the result. So what will be the result? Here is an empty type.
The result will be another JSON value, CERD.json.
Okay, now Iran 11 should complain.
Now it should complain. And now an example that we can do is CERD.json. Actually, yeah, I like this thing that you can use the macro. And this can be, I don't know, issue number, I don't know, 22.
7, yeah. But pass also the event, so I'm curious to see what's inside.
Event. Can we pass an event?
I mean,
okay, it's not super happy with this. What did I miss? Oh yeah, I forgot a parenthesis. Now it's not happy for some other reason. I don't think it likes the event.
What event dot body?
I'm not so. What is this Lambda event? Let's try to figure it out. Payload and context. Okay, we just want the payload.
Yes, e.payload. That will be a JSON, a CERD JSON value that can be part of a CERD JSON macro. Okay, cool. Now we have to change the state machine to include this.
To include this. So let's clean up a little bit.
In theory, when you do SEM build, should build also this guy.
Yes, except that we haven't mapped this one to SAM yet. So we need to add it to the template, I believe.
Yeah, let's do it.
Where is VS Code, the other one? There.
VS Code.
How do I remap environment? There, cool. Okay, so let's close this guy because... So we go to some config. No, sorry, some
template. We start from the template.
Yes, we start from the template and we need to add a new function.
That were more or less where you were. Yeah, fetch quote. Copy and paste fetch quote.
This is the state machine, right? Yeah, let's start from here. Fetch quote.
Yeah, we need a fetch issue number.
And now it's called fetch issue number. It's a serverless function. Code URI is fetch issue number.
The handler?
The handler, okay, now here there is a very specific syntax. Let me try to find it.
Runtime and handler now for Rust. What
Rust Lambda function with some. I'm searching in another window.
Oh, don't worry.
And there should be an official documentation from AWS, which is here. Actually, let me drop these links in the chat as well. So this is what we're looking at. Building a Rust Lambda function with cargo Lambda. So what we do is, okay, we need to do some stuff in our some config. So let's start by doing that. Some config.
Because it's still not.
Some reason it's still in beta. Now we can do some build beta features. I guess we don't need it if we pass it here. Some build, okay. Configure your SAM template. This is what we were looking at. So we need metadata, Rust cargo Lambda, build properties. What the hell is function A? Is the name of the function? Let's see if they have code that says function A.
Yeah.
Rust app, cargo toml source main. Okay, they are not using it here. So we need this metadata build method. In template, we need metadata build method. Then properties.
The URI seems fine. The handler is Bootstrap.
And
the
runtime
is
provided AL.
Yeah.
And architecture should be the same that we have.
It should be the same.
Yeah, let's keep this. Okay, architecture, I'm gonna remove it. Why does it like it? I was just thinking about it.
Take it easy.
Okay, so this should
now policies in line.
Yes, let's add it
in line there exactly.
And it's called this guy, fetch issue number.
There is a line 57 also.
Line 57.
After line 57.
Yes, because this is what we'll need to use in the other file.
Yeah.
So let's put it on top for consistency. Not that this is consistent in any way, but whatever. Fetch issue number.
ARN.
And fetch issue number function dot ARN.
Where is defined function? You called it.
I think it's we forgot.
We forgot to add function. No, it's just the name of that key. Yeah.
Let's be consistent.
Yeah, this time is better. And then we use that variable in line 54 on the left in the state machine.
Mm-hmm.
Okay, here we declared the function, the policy, and the ARN for the state machine. Cool.
Mm-hmm.
Let's go in the state machine.
So now here what we can do is do another step. Okay, now there is a question. If we have the issue number, we can use the issue number also in the fetch quote and fetch book steps. So probably we want to execute that before the three.
So it's before the parallel task. Okay, so where you have the cursor now.
So fetch issue number.
You have to change also line 12.
And we'll need to change this guy. Now the next of this one is fetch data.
Yeah, this is tricky. To insert a task in the middle is Yes.
Resource fetch issue number function error. Yes. Do we need anything else?
Try to scroll down to another task that we have to see if there is something.
Result
The resource,
selector.
output path, result path, the retry strategy.
Yes,
you can
let's
copy and
copy
paste the
all of
retry
this.
strategy.
And this could be important because we are doing an HTTP request.
Don't copy the end. You copied at the end also.
What did I copy? Oh yeah, you're right.
It's not the last one because it has to go to something. Well, in any case, if you specify a nest and an end, I hope it's giving you an error.
Okay,
You have
so
to
what
put
doesn't like?
You have to put the indentation to two spaces. That must be two spaces before. Just two. No. Just that line, two spaces. No, just that line.
Just this one?
Yeah. No. There. Okay, then he's indenting like it was, but cool.
Yeah, because I think this one also needs to be two lines.
No, but that is not important. That the four of them are consistently at the same indentation. It's not a problem. That is not important. The problem was that error equals and the interval in seconds were not on the same
yes.
vertical columns, and so that was not understanding what was going on.
Okay, fair enough. So now in theory,
I think with YAML you should put your indentation to two spaces and not four. But yeah.
In theory, now we should be able to do
build
some
and
build
deploy
and see what happens.
Cargo, Rust cargo lambda builder, cargo lambda build. Okay, seems to be building something in Rust. Or is just thinking about it.
It is busy doing something.
What is your CPU doing? Frying an egg?
Probably 90%, 100%.
Okay. We are frying eggs on Luciano's laptop. Is an Apple Silicon, an M1, 2, 3, 4, 5, 6.
Oh, nice. It's also building all the Node.js ones. Okay, so now I believe if we do LSAL, we will have a dot sum or something. AWS sum. So if we do AWS sum, I think here we have all the code. Build. Yeah, so we can check fetch issue number.
The other one will just be plain JavaScript, right?
And this is just one file because it's a single binary from Rust. And if we check another one, I don't know, fetch links, this one will be a lot more because this is JavaScript.
Is the JSON stuff. Is the JavaScript stuff, sorry.
Exactly. Okay, so now to deploy.
Some deploy.
I think some deploy is going to check that we have an AWS sum and use this one rather than using the straight source code as we were using before.
Let's see. Otherwise, you have to use some syntax, I suppose.
Otherwise, what we need to do is cd.aws_sum and then build. And then some deploy.
Let's try from here.
It did create another template as well.
Then let's try from here before to see what is thinking about it. I mean, it has in the template, in the root, you have the Rust stuff. So it's understanding that there is a Rust to deploy. Will it be smart enough to find also the build already done and recycle it? Or now it's uploading the create issue.
And it's the only one that has changed, so that makes sense. This is the only
one. Yeah, but there is also the new one in Rust. Add, okay. It's adding a role and a function, plus modifying a bunch of stuff.
Okay, do we deploy? See what happens?
Yeah.
Let's do it live. Come on. We need a song for deployments. I think if this works, I'm happy with this for the day.
Yeah,
but probably also if it doesn't work, we'll probably call it a day. But hopefully, if it works, we have a good starting point for doing more Rust next time. Okay, done. Let's see what happened. What did it do? So if we go to this guy, state machine, edit. So we have define default, apply default, fetch issue number, and then hello Hammers99. How are you today? So all of this stuff, yeah, let's execute it.
And remember that I ran true because now we put it back to false.
Good point. Good memory. Try run true if I can type today.
Dry Ryu is a forced fighter.
Did I do dry Ryu?
No, you wrote dry run.
Okay, cool.
Dry Ryu.
Don't scare me like that. Oh, fetch issue number. What's going on? It did work. Input, output.
What is the output?
Issue number 22. It did work.
We forgot to map stuff in the state.
Yes.
So the dry run is inside the event, is not in the root anymore. Because we forgot to do all the magic of taking the out. It's not mixing the input with the output.
Okay, cool. I mean, it did work as a dry run anyway. I'm happy that this Rust Lambda is executing. Actually, let's check the logs.
Yeah, the problem is that we forgot all the input-output with the dollar and the stuff. So the dry run got lost in there inside the event. That worked, by the way.
Look at this thing. It takes 1.39 milliseconds.
Yeah.
And 16
Instead,
megabytes.
the fetch quote, for example, how long is taking? Just
the
to compare.
Fetch quote.
That is not doing a lot, even that one.
56 milliseconds, not too bad. But it's 128 megabytes already.
Yeah, but 57 compared to, sorry, what was?
1 point something.
Yeah, okay. Guys.
Was 1.39.
Memory less than 158, but 16 used. The memory size is 128.
Oh, 16 used. Okay, well, let's see.
Yeah, but there is some numbers you can't go below because of
79 used.
79. Yeah, guys, it's a little bit different.
Okay, let's fix that mapping and let's try to bring this to a decent state.
We fix it through the result path and all this kind of stuff.
So how did we do it here? I can never remember. So output path and result path. Okay.
The result path, yeah, we have to do dollar dash something.
So we need to do this. And we call it dollar next. Let's use the uppercase. Next issue number. Right. And output path. What did we call it there? Issue number. So we can take issue number. Or not. No, wait, we want to take everything. This is always confusing.
Yeah, I want also to keep the dry run passing through. How do we keep the dry run passing through?
So how did we do it here? Here we get everything in the input, right?
Yeah, but then the result selector is creating the output of that step.
Mm-hmm.
You can have a result selector also here where you keep the
Yeah,
dry
I
run
think that's what we
you,
need to do.
you
Result
propagate.
selector. And we
Dry
need
run
to...
dot dollar colon, yeah, that one.
this is so annoying.
Issue number is...
or we need to keep the entire config, right?
Well, for now we just use dry run.
Why do we have config here?
Ah, yes, no, we have to keep all the config. Yes, you're right.
So if we keep...
is config dot dollar equal to dollar dot config.
Exactly. And then the other thing is next issue number dollar.
Only that is dollar dot, not next issue number, but is dollar dot issue underline number, because it was with snake case.
Yes, I'm just wondering, is this value
and I
going
don't
to be
think we need
available
result
here?
And we don't need result path, I suppose, at this point. There we need the next underline issue. What was the issue now? What was the, how do we call it?
Issue number.
Issue number.
But is this value going to be available there? That's what I'm wondering.
Oh, let's try. Then we call it a day. We can fight with this next time with the simulator.
Okay, let's try. Now we need to do some build. That's the annoying bit.
No, well, Rust didn't change.
But I think we always need to now update that folder with the template as well. It should be faster, but...
It's not building for you when you do deploy. There is no dash build or something.
You see, it did update the template. That's the thing.
Mm-hmm.
It keeps a copy of the template also inside.
Ah, okay. But deploy doesn't have a parameter to force the build.
Don't know. Good question. Why is re-uploading? Anyway, let's see.
He's liking it to upload stuff.
Okay, it's changing only the state machine. At least we are happy there. Yeah, I have to say that the only annoying thing of step functions that this state mapping stuff, it's not very easy to reason about.
No, not at all.
So try run true. Spell it correctly, please. Cool. Let's see what's going on there. Input is good. Output, it did fail.
Okay,
miserably.
We made a mistake.
The JSON path $.config specified for config could not be found in the input.
Because it's inside event. And if the Rust is not mapping the config, we lose it?
It is in the input.
Yeah, but it's not in the output of the Rust function. That one is complaining about is exactly what we output from the Rust function.
Okay, so what if we do... I think dollar is the output. So what if we do $$ execution? That input? No, that's gonna be the input of...
No, we need the output of the apply the false step here.
There must be a way to get the input of the current step
and merge it in the output. Something for next time?
I guess something for next time, yes.
Okay,
so I'm just gonna add a to-do here saying that to-do, this doesn't work. We need to take the input from
The previous step.
Well, the input for this step, we need to map, basically. We need to map using the input for this step as parameter.
Anyway, you can make a commit, go back to master, sorry, and deploy from master. So your
yeah,
Lambda
exactly.
is fine.
And I'll do all of that offline.
Cool.
All
so
right.
let's wrap it up. You can find the recording on YouTube. The link is in Twitch in the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday, 6 p.m. Dublin time. Make sure to check the Twitch link in the YouTube description and give us a follow so that you can be notified. Feel free to leave us any comment or open pull request. Everything is well accepted. We are trying to learn Rust and also step functions. So do not expect our solution to be the cleanest one or most pneumatic one. If you know any better way of doing stuff, please tell us. Thank you for all the questions in the chat and the participation. And are we going to raid someone?
Yes, we are going to raid. So stay tuned for more techie content. See you. Bye.
Bye.